Today, I'm fortunate to be invited by the AUR to discuss with you designing an educational research project. I'm Lonnie Sokowski. I'm a professor of radiology at the University of Wisconsin-Madison. If you have any questions, we'll save those to the end unless there's a really important question. Not sure how I'm going to see those, but somebody can alert me to those. So first off, the learning objectives that we have for today are describe the process of developing a research question built on supportive literature. That's going to be very paramount to developing your question and using the literature. Demonstrate approaches to developing a hypothesis and the specific aims that support your research question. And lastly, we'll discuss some challenges that are very unique to educational research that need to be accounted for, but also can be gone above to get the goal of doing your educational research project. So first off, before we actually begin talking about educational research, we have to really understand what it is. Basically, if you look at the American Educational Research Association, they define educational research as a scientific field of study. It examines not only the processes of education, but also of learning. The idea is that the research coming out of this body of work should shape our educational outcomes, and they seek to describe, understand, and explain how learning takes place. And that's what we're all wanting to understand is if we do this work, can we actually change our educational outcomes and understand where processes need to be changed? What education research is not, and what we see a lot of stuff happening in the medical education field, it's not about making a cool digital slide presentation or holding a conference or making a website or describing a new teaching method or making some cool 3D teaching objects. Those are all valid educational objects or things, but they're not educational research. If you're going to use something around those, you have to devise a project that incorporates those, not that is your educational research. So when we look at education, research in our body of radiology, we look at several domains. One is that we have this huge body of literature about teaching radiology, diagnostic radiology, interventional radiology, basically of teaching radiology. Then there's this other huge body of research or discipline that's called research on learning, and that is in itself a whole field. But we're looking at this intersection, this area, this smaller intersection of where research on learning and teaching of diagnostic radiology kind of bridges, and we can benefit from both areas. Some people will actually call this a specific discipline-based education research, and this is a field in itself called DBER. There's a bunch of research on this if anybody's interested. It's mainly in the physics and mathematic worlds, but it actually applies to medical education as well. So once you kind of say, hey, I want to do educational research, where do you begin? So the biggest thing is what are you interested in the sense that most educational projects take 2 years from the time that you start thinking about it to the time that you finish your project. And that's a minimum. So it has to be something that you're going to claim that you want to be involved in for that long a period of time. If you have an idea that kind of fleets back and forth, probably not the idea of developing a research project around it. The other thing is where do you, in your daily work life, do you see interesting ideas? I typically actually carry with me a notebook that I write down ideas at the work, at my workstation. Things that are kind of like I see them on a repetitive basis. I'll write an idea down, and after a while I get enough of those ideas and I page through them if I want to do a project, and now I have a whole bunch of ideas where I can start from. That's not your project, but those are some ideas that actually have been bugging you while you're working. Those are great places to start. There's other thing is public issues. If there's public issues that need to be addressed, those are ones that actually will stir interest in a multiple people beside yourself. Other ways you can do is, like, if you're interested in something, just kind of browse the literature and see what's out there. Sometimes that is actually enough to strike an interest in a specific issue. So once you get your idea, like just that basic idea that you want to do, now you have to start developing that question, and also even developing your idea a little bit more. So there's 5 big questions that you have to ask yourself. One is, what does this have to do with anything? Is this just like a kind of a fleeting question that you're answering, or does it really have anything to do with the greater discipline of radiology? If it really doesn't, it may be something fun to explore, but maybe not to develop all your time in doing a big research project. And then who cares about the results? If it's only you or maybe one other person, yeah, it may be fun to investigate, but not to develop or invest all your time in. And also, the other thing is looking at the literature. If we already knew this, what does it really add to the body of literature that's already out there? So don't repeat studies just to repeat them, unless you know that the study that was done wasn't valid and you want to check the validity of that. And those studies are very few to be done. Next thing is are you playing with black boxes? What that means is that you have an input and an output, but the methods of how those two things interact are unknown, such as basically you're evaluating an intervention or what people think or do prior to the intervention, and then you have this intervention like a training, classroom, education, or e-learning or something, and then you're asking some questions again after that. But the thing is you don't know what happened during that session that actually contributed to the outcomes. Yes, you can report the outcomes and the findings and stuff, but in order to make a change or to redirect the outcomes, you don't even know what happened in that session to cause those things, unless you have a specific intervention that will do that. Otherwise, those are black boxes. You don't really want to actually develop your ideas around them because it's really hard to prove and also replicate in different areas. The last thing is it research or evaluation? They're both valid methods of study. The only thing is you got to be true to yourself in the sense is if it's research, that's a thing that's hypothesis and specific aim driven. Whereas the evaluation, it's a valid method of study, but that's assessing an individual or program's progress in a certain area. So basically, you just got to kind of figure out where you are on that. That's also somewhat of an area of contention sometimes in the education literature. What is research or evaluation? But it's something that you got to figure out before you proceed. So once you start developing your question, the big thing is, and I can't stress this enough, is that you really need to brainstorm on your idea. It's almost like you have to live with it. You have to eat, breathe, and sleep with it. In addition, asking your colleagues, hey, is this an idea that we want to explore? Or the other thing is just saying it out loud or writing and rewriting the question. Sometimes you're actually going to take a good month to develop that good question. I mean, when I was in graduate school, we spent a whole semester developing what my professor called a burning question. So you got to be content with it's going to take a while to actually synthesize that question down. And also remember, your research question is not the same as your hypothesis. Your hypothesis is going to kind of come and morph out of your burning question or your research question, but it's not the same thing. So when you're developing those research questions, you got to really ask a lot of open-ended questions, you know, the how, what, and why. Those are the big things that actually need to be asked and kind of focused on. And then the other things to ask yourself is it clear? Does anybody that's not even familiar with your research, if you give them that question, and that's often a thing that's really good to do, is write down your question, give it to somebody who doesn't even know your field, and is that question clear to them? Do they understand what you're asking of your research project? And if they can say yes without too much extra explanation, then it's a valid question. The other thing is it focused? Is it focused enough to accomplish in one project? If it's too broad and that it's going to take you 5-10 years to actually accomplish it, if that's the goal of the bigger project, that's fine, but it should be focused enough that you can complete it in one project and not have multiple projects embedded within that one project. those are other additional projects that can be performed. And is it appropriately complex? Meaning you shouldn't be asking just yes/no questions or having yes/no answers when you're asking that question. If it is, then it's a one and done kind of thing. But you should actually, that question should be complex enough that you need to do research and analysis in order to figure out the answer to that specific question that you develop. Another criteria that's often used in getting good research question is the FINER criteria. And what that means is F stands for feasible. Can this be done with the number of subjects that you have access to? Do you have enough money to do it? Do you have enough time? And do you have enough expertise to actually perform the study? If you don't, you may actually have to ask for other expertise to help you, other experts in other areas of the discipline to chime in on your project. The other thing is I is interesting. Is it interesting to you, the peers and community? If it doesn't hold your interest for at least 2 years, it's not a project that probably is going to keep your interest long enough to complete it. And once you start a project, you invested so much time in developing a good question and developing the project, it's really important to try to finish those. Is it novel? Does it fill the gaps or extend the literature that's out there? Also, when you're writing a question or even a title of your project, or whether you're going for grant funding, if the project itself is novel or unique, that's actually the fulfillment of kind of filling that gap or that literature, the literature gap. However, don't put novel or unique in your question or your title. Usually, if it isn't novel or unique, it shouldn't be done. So they assume that by the fact that you're doing the research, it is novel and unique. Is it ethical? Can you get IRB approval for it? And sometimes it's helpful just to even talk to the IRB in early stages to see if this is something that they would let you go forward on. And is it relevant? Is it appropriate to investigate that topic or not? Some topics kind of are a little bit taboo, so those are maybe things that could be have difficulty in both the ethical and relevant categories. So when you're looking at the gaps in literature, now that you have your initial question kind of drafted, now what you need to do is go to literature, not do a formal search, just do a little search and actually see if there is something similar that's already been done in the body of literature that you're working with. And if you do see something, then you have to start looking for the gaps. And this is the process of where you may actually need to go back and revise your question. Sometimes this may take multiple iterations. And basically, once you get your question redrafted, you have to revisit the literature. So this is kind of a continual process until you kind of make a really good focused question. So now once you have your question, now you need to develop your hypothesis. So a lot of times we kind of think of education research as the soft sciences. However, it is really analogous to other types of scientific research. It sometimes doesn't seem that way, but it really has a lot of features that are similar, in the sense that you actually have a hypothesis that basically will give you some measurable outcomes. Those measurable outcomes will demonstrate some kind of an effect, and that those effects should actually go back and support your hypothesis. So a good developed research question with the hypothesis and the specific aims should actually fulfill this kind of cycle that is seen in other bodies of research. So when you're talking about developing your hypothesis, what this really means is a clear statement, kind of taken from your research question. It's a clear statement that states exactly what you intend to investigate. Its purpose is really to identify all those research objectives that you've actually been kind of drafting out in your question, and also identify those key concepts that are going to be involved in your research. And lastly, it should basically be able to take the problem statement that you developed in your question and relate it to the literature review and show that how those two things are related and how your problem statement is going to extend that literature in essence. There are a couple different types of hypotheses, but initially that first hypothesis is actually a declarative statement. It basically says exactly what you expect to come out of your research. Basically, it's kind of like that's what's going to happen, and you're basically making a declarative statement. So in essence, though, there are two types of declarative statements for hypothesis. You can have a directional hypothesis, which implies that there's going to be a difference in the particular direction when you're comparing two groups, and we'll give you an example of this in a second. And the other type is a null hypothesis, and that's a statement that you expect no difference in the outcome between the groups that you're studying. So once you have your hypothesis developed, now it's actually the time to develop your specific aims. Sometimes we actually want to kind of lead ahead of time and kind of go into our specific aims, but you have to really and truly, in order for your specific aims to actually be appropriately fleshed out, you need to have your hypothesis first. And your specific aims should actually outline all the key steps of how you're going to fulfill your objectives that are in that hypothesis. And then it will also address all those critical needs that need to happen, and they will flow logically from one step to the next. So you can actually have like 2 or 3 specific aims under each hypothesis that's going to basically flow from one thing to the next to get to that solution. So for an example, I just pulled this article off of a literature search, and it's from the Journal of American College of Radiology. Just a random project, but this project is related to radiology and an educational outcome that they are investigating. So it's cross-sectional examination interpretation discrepancies between on-call diagnostic radiology residents and subspecialty faculty radiologists, an analysis by imaging modality and subspecialty. It's a very focused title, and it's not basically claiming to be novel or anything. They just want to evaluate how those two groups are doing. So we break down and look at that, and I wasn't part of this research or anything like that, but I'm like looking at theirs and kind of breaking down like how this probably developed. Their initial research question was, how do radiology resident exam interpretations compare to radiology faculty? However, that's too broad. That's basically taking the whole department and actually kind of figuring out. That's too many variables to account for, too many studies to look at. But a more specific way, and what they actually chose to do in their project was something like, how do cross-sectional exam interpretations compare between on-call residents and subspecialty radiologists? So this is their question. They're looking at two groups, the on-call residents and the subspecialty radiologists, and then their focus is on how they handle cross-sectional exam interpretation. So that's very specific and very focused. Now taking that research question and changing that to a hypothesis, and because it can go either way, this is an example of a null hypothesis, where residents on call perform similar to subspecialty radiologists on cross-sectional exams, both CT, MR, and ultrasound, versus taking that same approach and actually doing a directional and saying residents on call perform inferior to subspecialty radiologists on cross-sectional exams. So that's a way that you can take it, depending on how you want to pursue your study. So it's important to develop your hypothesis first before you do the study. Don't develop your hypothesis afterwards, and then that's how you actually approach it. So once you have your hypothesis, the next thing to do is develop your specific aims, or otherwise think of it as your approach to do your research. In this case, what they needed to do is collect the resident preliminary on-call interpretations from the ER inpatient and urgent outpatient exams for a period of 9 months. And so they basically collected all that stuff. Their next task is to evaluate the graded preliminary exam interpretations in their modified RAD peer by subspecialty. And then their third thing that they're going to do is compare the outcomes for any similarities or differences. So basically now you know what they're going to do and what sequence they're going to do it. And that's how your specific aim should go from, and they should follow a logical sequence of how you're going to perform your research. Now shifting a little bit of the gears, because we kind of talked about things that medical or educational research is not. Here's just some examples of things that could represent medical education research, just some ideas out there. Evaluating a clinical performance to determine if training methods need to be revised. So that you evaluate that clinical performance, and then once you analyze what the problem is, then you actually can do some kind of intervention or change how the mechanism of performance is going to be measured, or do some kind of intervention, and then you actually study it again after that revision. That would be a great kind of study to do in medical education, especially in radiology resident training. Another would be to evaluate performance or other measurable outcome in simulation procedures like urgent procedures, on-call preparedness, reading interpretations, kind of like what that prior study actually had shown. Looking at awareness of ionizing radiation and safety in residents and in faculty, or even in our technologists, would be a great study to understand. And that could also lead to another intervention and then a revision, going back and studying it again at a later time. Evaluate practice patterns and error rates. This would actually also lead to that kind of like looking at what they are, planning an intervention, and then doing a follow-up study. Now that we've looked at like how to develop educational research, you have to be aware of some of the challenges that can happen with educational research. One is that there's a true lack of funding. The majority of educational research that happens, especially in medical education, is unfunded or self-funded. Sometimes you can get some small grants to do some pilot studies, but it's super difficult to get funding for those multiple year or multiple institution projects unless you can find some kind of way that you can twist it to get some bigger funding from like NIH or NSF, or sometimes even the DoD, depending on what your educational area of research is. There's also, you got to realize that sometimes there's going to be a lack of appreciation or recognition for what you've been kind of putting in there. Don't let that get you down. You got to do what you love. Basically, that's kind of what you have to actually kind of focus on. Other things that you have to understand that educational research projects can be really challenging to perform well. Part of it is that we typically have small sample sizes. Most of the time, if we're looking at radiology residency groups, we only have a small amount of residents in any program, if that's your educational focus. And it's also really hard to get control groups. I mean, most IRBs will not let you do, especially the educational IRBs, will not let you do a control group that has no access to that educational intervention that you're going to try. Unless you can prove a valid mechanism of a different type of a control. And also, because we're doing these studies in a small discipline, it's really difficult to generalize these findings to larger groups of learners, such as nationwide or international. Because our teaching methods can be very specific, it may be part of that inability to generalize. There are some other possible alternatives to having a true control group, and one is to do some observational studies rather than an interventional study, where you have case controls where you're basically looking at people that have a specific factor and those that don't. For example, think about students who read well versus students that don't read well. And basically you're kind of observing them, and is it because how many books do they read, how much video games do they play, how much TV do they watch. The problem with case controls is that it's frequently retrospective, and it can actually impose some bias because people may remember differently than how it actually occurred. You can do case series, which is basically you track subjects that have specific features or quality. Those observational research things are really difficult to actually do, and they take a long time, and they have a lot of qualitative methodology that's also can be difficult to analyze as well. Another way to study it is repeated measures, where basically kind of like this, where you have group one actually acts as a control in the first part of the study, where group two gets to do the intervention or the test, and then halfway through they switch. So each group is exposed to the test environment, and each group serves as its control. There's just some specific analysis that you would do because you have basically two different types of situations. But also remember that a lot of educational research is more qualitative than quantitative. And when it comes to publications, most publications, especially in the medical field and scientific fields, favor quantitative methodologies. You can get these published, but you may just have to actually state your case a little bit harder to do so. So some other last special issues that arise in medical or educational research is that there's true lack of empirical studies in medical education. And when I say that, it's like you want to base your studies on empirical studies. However, they're hard to find to be a model for how you should go about your studies. And the difficulty of having those true controlled studies, and also blinded studies are difficult because teachers and students actually kind of talk amongst each other, so it's really difficult to have a true blinded study. And also when you're talking about controlled studies, even if you're able to do a true controlled study where you have one half of the class doing one thing and the other half doing another thing, I've seen in my experience that students will talk about the exam to the other students, so really and truly it's not a true controlled study where you can prevent all those cross variables. Surveys can be good. The problem is that even within your own institution, you only have an internal response rate of like 30 to 40%. And externally, if you take and go outside of your institution, you pretty much average that 10 to 15%, which actually can really affect your results. So you're making assumptions on a small you're making assumptions on people who only respond, and you would love to actually hear what other people actually have to say that didn't respond. When you're looking at evaluation methods, the multiple choice questions are the least biased, but they also lack that rigor that you really want to get at in terms of that complex knowledge and attitudes. I mean, you really want to talk to some of the people to get the idea of like what they're thinking. One method that can be used a lot in education is called think alouds, where you actually have them do an activity, and while they're doing that activity, you just have them keep talking, and anything that comes to their mind that you want them to actually keep talking about what they're doing. That's a really rich form of qualitative inquiry. It's a lot of coding that you have to do at the end, but it's actually reveals a lot of good results. And that's what I'm talking about. These more complex methods may require you to do some a little bit more training, or recruit somebody from an educational field to actually help with some of those things, just because they get more complex. And in terms of how to code qualitative transcripts can be really challenging. So some practical long-term outcomes that actually can be a problem with educational research is it's really difficult to attribute what you've done in that one educational topic back to, or attribute it back to that single educational event. There's so much kind of cross things that happen. Students come with prior knowledge, and you can't always attribute that what you actually did with them is because of that educational event, unless you can actually make it really specific and really focused. And also sometimes it's difficult to tell whether or not in that specific instance, if the knowledge that you've obtained from your subjects is just due to memorization versus they truly know that knowledge, because your span is so short sometimes. And ultimately, we would love to know that what we did for our research project had an effect on medical education long term, such as job success and clinical practice outcomes. Sometimes those are really hard to prove. You can kind of make kind of like that it likely does that, but you might not actually prove that. It may have some correlation to it, but you might be a little bit pressed to say that you've proved that outcome. So lastly, I'd like to just talk about some take-home points. The big thing is to really identify that area of interest or that passion that you have. Having that is actually really key to making a successful research project. And really finding that need that is in the literature by asking those questions of colleagues, of friends, looking for those gaps in the literature. Once you isolate those, that's actually a good place to actually be successful doing a research project. There's always things in the media and the public sector that sometimes if you take some of those ideas and you bring them back into the practice patterns, that can actually develop a nice research question. And then basically take your time to develop your research question. Like I said, it can easily take a good month to just develop a really solid research question that can be made into that research plan. In the research plan, make sure that you develop your hypothesis, and then upon that hypothesis, develop your specific aims that are in a sequential and logical order. And lastly, realize that there's a lot of challenges to educational research that go beyond the scientific research. But if you can get your idea and keep it focused and stay with it, it can actually yield some great results and really have some fun with it. I know in my practice I've actually had some fun doing some educational research projects, and each project that I've done actually has yielded some other questions. So don't be closed on those, because you will develop questions as you're going along. Just keep a notebook, jot them down, and go from there. So here's a list of the references that I've used for this talk. You're welcome to look further into any one of them. And thank you for your attention and time. And if you have any questions, I'd be glad to answer them.
Yeah, so I just want to make sure.
Hello? Any questions?
So it's August is fine because I'm not going to be away then. I don't think I have any vacation then. So I just actually email.
Are there any questions that I can answer?
Hello?
Hello?
Hi. I put in a question online. One of the challenges faced by some radiologists is the lack of colleagues who share a passion for education and educational research. So I was curious to know what you would suggest for somebody who might be in that situation so that they can still obviously undertake very thoughtful educational research.
Yeah, that can be a problem. I think that sometimes if you're, this sounds kind of a little bit odd, but sometimes if you're feeling that way, there's probably somebody else in your department that feels that same way. It's just that most of our departments are so spread apart that we don't actually have the opportunity to talk with each other. But the other thing is if you go to the AUR, there's like a ton of mentoring committees that you can actually start to get involved with that way. And sometimes you end up seeing your same colleagues at some of those meetings. I know I have, not realizing that they are actually involved, they're interested in the same thing that I am. I think if you actually reach out to people that are especially in AUR, if you do that, you can actually potentially even do a cross-collaboration project within, you know, both your place and someplace else. The hard part is that you'll end up needing 2 IRB approvals, one for your institution and the other institution. But it can be done, and don't give up. I mean, I think another thing you can do is talk to your chair to find out if there's anybody else out there. The other thing is don't forget your vice chair of education if your department has one. That's a good place to start with because they typically know who's doing some educational research that they can hook you up with.
Hello?
Yeah, go ahead.
Hi. Yeah, I'm a neuropathologist. I'm not a radiologist. I am involved in research, though, in imaging, especially pediatric CT and the radiation exposure for the past 6 years or so. I've been very chagrined to see the response of agencies like the ARC, which essentially is a very tepid response for radiology types of issues and grant submissions. Can you give me like your list of top 3 agencies that have come through with funding and are interested in educational topics, whether it's for the caregivers or patients or for health profession students, either one of those groups, your top 3?
Okay, places that I've gotten my grants from actually one has been my university. I've gone as far as going up into the provost office, and I've gotten a couple of grants that way. I've also have gotten a couple of grants through the RSNA, through the Education Scholars program. And those are, you know, those are kind of like your low-hanging fruit that you got to try to grab onto. But right now, I'm in the process of going to the NIH, and there's a couple of them out in the NIH. You have to work with your grant officer. The hard part is to take your topic and swing it a little bit to what they want, and then you get also a little bit from it. You know, because like right now I'm working with the AHRQ and taking my project to look at it from a patient quality standpoint and looking at it that way. So that wasn't initially my focus. I wanted to just do this project, but I'm actually looking at the grants and actually swinging it to part their focus. I get what I want out of it, and they get what they want out of it.
Mm-hmm. Okay. Well, that's interesting that you mentioned the NIH, because I've yet to see subject lines that are tailored to this. But anyway, thank you very much for your presentation.